Okay, transactions and capacity. So big enterprises, they have to deal with a lot of transactions, dozens, even hundreds of transactions per second. And that's averaged over the day. So during regular shopping hours, right, regular daytime-ish hours when most of the shopping happens, the numbers are actually about twice as high, even higher during major shopping events like Amazon Prime Day, and still growing. Now, each transaction that happens throws in a bunch of data. So the actual transaction itself is a pretty small part of it, right? The list of items that are being bought, the credit card number, that sort of thing. There tends to be a lot of supporting information around that. So all the text and pictures, video, everything that's associated with the transaction itself, right? Clicking on things, the web pages, all that. Then tack on top of that, browsing involved around the purchase, because most people view a lot of items before they actually pick one. And then a whole cascade of secondary transactions. What do we mean by that? Well, suppose you buy something on Amazon. Here you are, you're up in the corner here. And here's Amazon. Right, so you click buy. Let's say here's you. Here's Amazon. Okay, and then what happens? Well, a whole bunch of things. First of all, Amazon sends your information to a credit card company. Okay, and the credit card company has to respond back. Amazon's going to send some information to a shipper, and the shipper is going to have to respond back. So let's say UPS down here, I don't know. And what else do we have? And then all of Amazon's internal analytics, for example. So things like inventory management, warehousing, notifications, sellers, internal analytics, right? Like item popularity, web analytics, right? What else? People bought this, bought that, quantity updates on pages. A lot of stuff has to happen, right? So every time you do a transaction, there are all these little secondary things that are happening, and there's a whole flood of them. There's all kinds of data that Amazon tracks, and likewise, any of these other operations, these credit card operations, UPS people. I mean, think about the credit card people, all the transactions they have to handle worldwide, right? Amazon is just a fraction of that. So yeah, they're all pretty busy. Okay, so to be competitive, big retailers have to have robust, high-performance systems. Robust means they're not going to fail often or easily, and they have to be high performance. They have to be able to handle a lot of traffic. They can handle this immense traffic volume. It's a big deal. I mean, think about how long it takes just to do one search for a file on your machine. If it worked for that, if it went that slow in their systems, they'd never get anything done. These stuff all has to get processed super fast. All right. History of transaction processing systems. Well, once upon a time, they were basically all manual, right? People wrote down whatever happened, and that was what there was. Eventually, computers came into the scene around the 50s and was first used for things like payroll and other sorts of cumulative payments. So at the end of the week, you total up all the numbers and you'd say, okay, Joe, here's how much you get paid for a week's work based on how many hours you put in. That was how come they had those punch cards back in the day. Every day you went to work, you clocked in, and then at the end, they'd gather up all those cards and put them in the computer, and that's how they knew how much to pay you. But again, you wouldn't do that with the real-time system. It didn't make sense with payroll anyway. You wouldn't pay people for every millisecond that they're on site. You just say when they check in, when they check out, you get paid according to that. Eventually, though, they came up with some real-time systems. So the first one of those was something called Sabre. Sabre was a flight reservation tool. So prior to that, if you were on a flight and you had to change it for some reason, it was a huge pain in the ass, and it used a pencil and paper system. So basically they had to pull out the manifests of any plane you wanted to look at. They had to go in there and figure out, oh, here's an open seat here. Would you like this seat? And it took a while. It took like literally hours to change a flight in many cases. With Sabre, that time went down from hours to minutes because it was all done through computers. It was a huge breakthrough in the field of reservation software. Still used today. Its descendants are still used today by the various airline companies. It was developed by American Airlines back in the day. Of course, various real-time systems, right? In the brick and mortar era, before the internet, most transactions happened in person. There was a representative of the business there to help you with anything, some cashier, or for banking like a teller or a travel agent, things like that. It would happen in real time, but they would be assisted by a human. But with the online era, we started to see all of this stuff is automated. There's not really a human there. The system is fully automated. They're remote, they're unassisted. You just go to the site, you click on some things, you press some buttons, and the magic happens. And now we're in the mobile commerce era. So there are a lot of applications out there that allow you to use mobile devices to replace cash or credit cards. My wife, for example, she goes to Target pretty regularly, and I often say that corporate must have a statue of her somewhere, but she's, you know, she pays with her phone. Hold on, we got dog problems. Dog, quiet. Vile beast, get in here. All right. You're okay, buddy. Okay. Now, current state, roughly speaking, the amount of annual traffic sent over the internet is about 3 zettabytes. Might be up to 4 by now. These estimates are always a little off. Estimate for 2025, people are saying 5 to 10 zettabytes, maybe more. We'll see what happens. Yeah, a lot of that is video streaming, right? So the big sources of data these days, Netflix, Amazon Video, YouTube, all the streaming video, that's where a lot of it is. Only a small fraction of it is these sort of commercial transactions, but there's still a lot of commercial data going on. And for most organizations, if you're surviving, then you're growing. And if you're growing, then the scalability of your systems is something you worry about. So data volume for a lot of those businesses increasing at 20 to 50% for the next few years. Again, typical numbers there. Applications are becoming more complex. So yeah, you could use faster hardware to do that, but it's going to be more expensive. In most cases, what you want to do is have partial deployment of applications, like we talked about with virtualization in the cloud. You don't want to just get a lot more pieces of hardware running in parallel. You want to do a better job of allocating the applications you need and the quantities you need over a smaller set of hardware. All right. And again, many organizations are doing this as part of shifting to the cloud. So they're saying, you know what, we'd have to redesign everything under our own roof anyway. Why don't we just run these applications in the cloud and let them deal with it? Why are we doing this under our own roof if we're just going to shift to the cloud in a couple years anyway? Okay, so your basic transaction structure, I think this will be the last slide I do today, follows some kind of request agreement sequence. So the basic model is you ask to do something, like for example, add a product to a cart, and then the enterprise either agrees to it or doesn't. So for example, you are looking at a web page, the web page says there's still a few of this item left, you click buy it now, and that goes through or it doesn't, right? It's probable that it will go through, right? You will be able to add it to your cart, but it's possible that in the milliseconds between, you know, when you thought about clicking it and you actually did clicking it, that somebody else on some other machine actually bought that same item at the same time. For example, if you're 2 people are on eBay and there's one thing for sale, well, they can't both get it, right? Somebody's going to have their transaction process first. Anyway, but you browse around the site for a while, you try to add some things to your cart. When you're ready to go, you say, okay, I'm going to check out. And then again, the transaction happens or it doesn't. For example, you add in your credit card number. Did you enter it in correctly? Did you enter in the right security code, the right expiration date? Is the credit card system available? Maybe they had some hang up in the hardware. Maybe there was a server failure somewhere, whatever. If everything goes through and the data is all correct, sure, it goes through, but for a variety of reasons, it might get hung up somewhere. And there are often other sorts of secondary request agreement pairs. For example, you give your credit card number to Amazon. Amazon's going to cross-check that. You know, they're going to send that to the credit card company to get a verification. The credit card company itself is probably going to check for fraud. And, you know, eventually they'll contact Amazon back and say, yep, thumbs up or thumbs down. Now, in general, in a well-designed system, any final changes to the data don't happen until everybody agrees that the transaction is going to happen. And this leads to a couple of basic models and ultimately to something called the two-phase commit transaction model that we'll talk about on Monday. All right, this is a good break point. It's passable. I don't want to get too deep into these things. We have plenty of time to go over everything on Monday. So I'm going to pause it here and